Welcome again. Today, we just did the quiz. Take my notes serious, please. Now, today I was planning to cover these three topics: subroutines, stack frame, and local variables, parallel I/O, force, and interfacing. But probably, with the much time we spent with the quiz, maybe the interfacing part is not going to be finished today. We're in chapter 4. If you remember, last time we started, it's about advanced assembly. We talked about the stack. What is the concept of a stack? Last in, first out. What are the stack instructions? Push and pull. And some examples. And we're here at the subroutine. طيب, what is a subroutine? A subroutine is a piece of code.
أنت مشير إشي؟
والله, I thought I was. No?
لا ما في شيء.
Okay. Okay. Where is it? Where is Zoom? Thank you, Yazid. I didn't share. So I was talking, these are the topics I was planning to cover today. The quiz took too much time. Now we're going to start with subroutines. Last time, in chapter 4, we introduced the stack, how does it work, and we gave examples. You can go back to the recording of last time. And today we're at the subroutines. Okay, what is a subroutine? Anybody wants to answer? No? طيب. A subroutine is a piece of code that is executed off sequence, meaning we said our program, when we convert it to machine code, it is in program memory, right? In the flash memory, right? This is the flash memory, program memory. And here you have your instructions. Yani instruction مثلا the push or the pull or whatever has the push مثلا two memory locations, machine code. We know how to push, pull, 3 locations, right? The program counter points to the instruction that is to be fetched to the CPU to be executed. After this first instruction is fetched and starts executing, the program counter automatically increments to point to the next instruction to be executed. And whenever there is a place in the queue, the instruction queue, it is fetched. So it will be ready there for execution once the one before it is done execution. Then, after this instruction is fetched, either it's 2 locations, 3 locations, 4 locations, 5, whatever, the program counter increments to point to the following memory location. So the program counter fetches instruction, the CPU execute instruction sequentially by moving to the next instruction, next instruction, next instruction. Okay? A subroutine is a piece of code like the delay code we did last time in our blinking LED program. Let's say you have 10 instructions that take 10 locations. If you want to do the delay here, these will consume 10 locations. Okay. If you wanted to use it again here, مثلا, you're gonna reserve 10 locations, or again 10 locations. While you don't have to do that. Let me go to my board. Okay, so if this is the program memory, okay, we have, for example, 10 instructions, okay, that do something, مثلا delay or something. Let's say delay. So if I want to do, I do my something, then I want to do delay, this will book 10 locations, delay. Then you do other stuff, you turn on the LED, you do more 10 locations, delay, right? So you're wasting memory locations by doing the same thing over and over again. Instead of doing this, keep writing these instructions over and over again. You can write them once, and in the program memory, you can just go to some place in the program memory, write these 10 locations, okay, call them مثلا my subroutine, put a label here. Let your program execute. The program counter keeps moving sequentially. Okay, here you want the delay. You can use an instruction called branch to my subroutine. This instruction will affect the program counter, make it point to the memory location where my subroutine is. So the program counter, instead of moving to the next location here, it will go off sequence and go point to the first instruction in this subroutine, or we call it a subroutine now, in these 10 instructions. When you're done with them, you can call an instruction at the end here called return from subroutine. The return from subroutine will send the program counter back to where it was before we branch to the subroutine. Now you start moving again. If you want the delay again, you can branch again. Branch to my subroutine again. This will send the program counter here. Do the work. When you return, when you're done, it returns you back to here, to after the branch, because while the branch is executed, the program counter is pointing to the next instruction to be executed, not the one currently being executed. This saves program memory space. It adds overhead overhead by or delay by because it has to change the value of the program counter. This is not necessarily if this was sequential, right? So replacing these 10 instructions, 100 instructions with one instruction. Okay, so it's like a function in a high-level language in C. You write it once, you call it. What does this call it mean? It means send the program counter to point to that piece of code and start fetching instructions from there. طيب, when done, how do we return? Then this address of this location has to be stored somewhere. So the return can go back here. So whenever a branch instruction is executed, the current value of the program counter is stored in the stack. The current value, the next instruction to be executed, is stored in the stack. Then the program counter is given a new, number one. The program counter value is stored in the stack. Number two, the program counter is assigned a new value, which is the value or the address of the first instruction in the subroutine. The return instruction, what it does, it goes to the stack, it brings the value stored in the top of stack, okay, top of stack, and stores it in the program counter. So this will result in the program counter going back here. To see this in the data sheet, let's search for the branch instruction, branch to subroutine, BRA. So to call a subroutine, to call a piece of code, you need to branch. Okay. Where are the instructions? Okay. Here. Let me just find it here. BRA.
دكتور هي مش موجودة على فكرة بالجلوسري، كان
بي ار ان
بي ان اي هي فوقيها، بي ار ان وهي فوقيها جاي بالصفحات، مش موجودة هون. اضطريت اروح عليها بالامتحان ادور عليها هناك.
بي اس ار بس البي ار اي تزبط باي ذا واي. anyways بي اس ار برانش تو سب روتين. احنا وي روت كود صح برانش بي ار اي didn't we؟ anyways بي اس ار برضو. what does this instruction do؟ بي اس ار يعني to understand what an instruction does. let me take this screenshot here, take it over there and see what the instruction does. With the reverse, let's look at them together. RTS, return from subroutine. This is the last instruction in the subroutine. And this is what it does. Okay, so let's look at them, both of them. Oops, sorry. Okay, so the branch to subroutine, what it does, هذه number one. What it does, it decrements the stack pointer. So you have a stack pointer pointing somewhere initially to the first address after the last memory address in the RAM. It decrements the stack pointer by 2, right? Hi. So 1, 2. So if this was 4,000, this will be 3F F F 3F F E. So this new stack pointer will be like this. It will point to here to 3FFE. Then 2, return address high, return address low are stored in these two memory location where the stack pointer is pointing at, and the following one will underneath it. What is the return address? The return address, if this is the data memory, we call BSR here, BSR to branch to subroutine here. My subroutine, okay, branch to my subroutine. The program counter, while this is being executed, is pointing to the next instruction that will be executed next as per the expectation of the processor. So this address, so if this was at memory location مثلا 4,500, at 4,500, this will be 4,500. Well, we need to check the size of the branch to subroutine, right? To know how big it is. The branch to subroutine is one location. The branch to subroutine object code is one location. Okay. So for 500, 1. So the program count, while this is executed, when it's executed, the program counter is pointing here. So I have to return back here when I'm done with after the branch. So this address needs to be saved here in these two locations. So 4501. ماشي. Then the program counter plus the relative branch to subroutine. There is a branch to subroutine and jump to subroutine. I'm going to show with both. Plus the relative address to program counter. So the new program counter value will be مثلا هذا is مثلا 10 or 100 locations away from here. This is relative addressing mode, if you remember. ماشي. So the program counter will be 4,501. Well, let this be, let it be مثلا 10 locations in hexadecimal. Okay, in hexadecimal 10 locations. This will be at address 4510, right? 10. So the program counter value will go point here after you give it the current value plus the relative, okay, where the label is at. Now, You're here, you're going to execute this code over here. You keep executing until you reach an instruction called RTS. RTS, returned from subroutine. What this does is two things. The two locations at this memory where the stack pointer is pointing at goes to the program counter, high and low. So the stack pointer is shown here, goes to program counter. So when this is executed, program counter is given the value 4501. Hence, it goes back here where it was when the branch was executed. Then the stack pointer is incremented by 2. 1, 2. So goes back here. So these are empty. ماشي? So a subroutine is a piece of code that you access off sequence by sending the program counter to that location, execute the code, then go back when you're done. How do you go? You call the subroutine or branch to the subroutine. How do you return? You return from subroutine. Okay. Now, types of subroutine calls are 3 types. First, there is instruction is called branch to subroutine, BSR. We just saw it. This uses the relative addressing mode, which means it can the address is going to send the program to is the current address plus 127 or minus 128, above it with 128 locations or underneath it with 127 locations. Okay. Or to jump to subroutine, what you provide here is the actual address the program counter is going to go at, and this could be an address, 16-bit address, which will cover the 64K address range. The call subroutine, you can go access code. You know, we said that memory, the program memory is split into 64Ks, right? 64K, and each one of these we call it page. How do we change pages? There's a register called P page, and I'm not gonna go in details here. ماشي. But both the branch to subroutine and jump to subroutine can send you within these 65,000 location to any location to branch to execute some code over there. Okay, but what if you want to go execute some code in a different page? You do a call. A call will change. So the branch to subroutine, jump to subroutine, these both of them only affect the program counter. The call will affect the P page register plus the program counter. So it can send the program counter to a memory location out of the current page to another code page. The return from subroutine within the same page is RTS, return from subroutine. If you went to another page to execute a subroutine there through a call, you return by RTC. Why are they different? Let's check real quick, and this is probably going to be the last thing. BSR, see, these are the instructions. BSR, branch to subroutine instruction, only saves in the stack, only saves what? The program counter value. ماشي. While the jump to subroutine instruction here, well, okay, before this, any branch to subroutine, but only also saves the return address. But the new value of the program counter is the subroutine address, the actual address. While the BSR, because it's a relative addressing mode, it gives the current program counter value plus the relative, how far it is from our current location. طيب, the call, see the call, it saves the stack pointer, the return address, اللي هو the current program counter in 2 memory locations in the stack, okay? And it saves the P page register. So it reserves 3 locations from the stack, 2 for the program counter, 1 for the P page, okay? then the new page goes to here. The new program counter value goes to the program counter. The RTS, the return from subroutine, brings back the top of stack, the most two locations on top of the stack back to the program counter, while the RTC here returns the most the top of stack to the P page register, then the following 2 bytes to the program counter. Okay. So this is about subroutines. We actually use subroutines. If you want, these are examples. This is the BCD ASCII code example I did in the flipped classroom demo lecture. It's there. This is the same code, but what he did, instead of writing this code in the middle of the big program, he wrote it underneath, made a label, binary to decimal, colon, and then RTS. Whenever you want this code to be executed, you say BSR binary to decimal. That's it. It will go execute, send the program counter, execute these, and the RTS will return to where it was. Okay, next time we'll see how we'll pass parameters to subroutines, stack frame. Okay, we need to move faster. And okay. So my request, guys, that you, following our discussion before, okay, please revise the material that we take, okay? Take 10 to 15 minutes before every class to revise what we talked about in the previous class. If you have any questions, you may stay until I stop the recording. Thank you very much. See you next time on Wednesday.